Yes, 2/0 copper metal clad cable is acceptable for feeders. According to the National Electrical Code, Article 392.10 bone allows metal clad cable to be used as feeders. Table 392.10 B2 specifies the minimum ampacity of the grounding conductor in metal clad cable based on the size of the phase conductors. For 2/0 copper phase conductors, the minimum grounding conductor size according to Table 392.10 B2 is number 6 copper for ampacities up to 200 amps. The sheathing of metal-clad cable provides an equipment grounding path which is equivalent to a number 4 or larger grounding conductor. Therefore, the combination of the sheathing and the number 6 grounding conductor provides sufficient grounding protection for 200 amp feeders. Articles 300.15 and 300.22 require service entrance cables to be protected from physical damage. If service entrance cable is used, it must be completely covered by sheetrock or installed in a conduit or other approved raceway. Metal-clad cable does not require additional protection from physical damage, as the sheathing provides sufficient protection. In conclusion, 2/0 copper metal-clad cable with a number 6 grounding conductor is acceptable for use as feeders in a building that requires either service entrance cable to be covered by sheetrock or metallic cable to be used. Let's delve a little deeper into the specifics of metal-clad cable as feeders, especially focusing on the grounding requirements and the National Electrical Code references. Firstly, we'll revisit the allowance of metal-clad cable as feeders. The NEC, specifically Article 392.10 bone, explicitly permits the use of metal-clad cable as feeders. This is a crucial point because it establishes the basic legality of using this type of cable for the intended purpose, provided that all other relevant requirements are met. Secondly, we must consider the size of the grounding conductor. Table 392.10 B2 dictates the minimum size of the equipment grounding conductor within the metal-clad cable assembly. It's important to note that for 2/0 copper conductors serving a 200 amp panel, a number 6 copper grounding conductor is the minimum acceptable size. This might seem small relative to the size of the feeder conductors, but the NEC accounts for the supplementary grounding path provided by the metallic sheath of the metal-clad cable itself. The significance of the metal-clad cable sheath cannot be overstated. The NEC recognizes the sheath as contributing significantly to the overall grounding capability of the cable assembly. It acts as an equipment grounding path, effectively supplementing the grounding conductor within the cable. The code considers the sheathing of the metal-clad cable to provide grounding performance equivalent to a number 4 or larger copper conductor. This is why a smaller grounding conductor, such as number 6, is permitted in conjunction with the sheath for 200 amp applications. It is essential to understand that the combination of the sheath and the internal grounding conductor provides the complete equipment grounding path. Individually, neither the sheath nor the number 6 conductor might meet the full grounding requirements, but together, they provide adequate protection. This is based on the impedance of the fault current path and the time it takes for overcurrent protection devices, such as circuit breakers, to operate and clear fault. Furthermore, the NEC addresses the physical protection requirements for different wiring methods. While service entrance cables must be protected from physical damage, often by being covered with sheetrock or enclosed in conduit, metal-clad cable inherently offers a greater degree of physical protection due to its robust metallic sheath. This is why the NEC does not typically require additional physical protection for metal-clad cable in applications where service entrance cable would require it. It's also worth mentioning the specific application of these feeder circuits to supply 120/240 volt panels. In this type of system, the grounding conductor plays a crucial role in providing a low impedance path for fault currents, which helps to ensure the rapid operation of overcurrent protection devices. A properly sized and installed grounding system is essential for electrical safety. To summarize the key points: 1. Metal-clad cable is permitted as a feeder wiring method under NEC Article 392.10 bone. 2. For 2/0 copper feeders, a number 6 copper grounding conductor is permitted by NEC Table 392.10 B2, provided the metal-clad cable assembly is listed and labeled. 3. The metal sheath of the metal-clad cable contributes significantly to the equipment grounding path, supplementing the internal grounding conductor. 4. Metal-clad cable generally does not require additional physical protection in locations where service entrance cable would. 5. The grounding system is essential for electrical safety and must be properly sized and installed. It's important to remember that electrical codes and regulations can be complex and may vary depending on local jurisdictions. Therefore, it's always advisable to consult with a qualified electrical inspector or engineer to ensure that any electrical work complies with all applicable requirements. Let's now consider some additional details regarding the installation and termination of metal-clad cable to ensure compliance with the NEC and best practices. Firstly, it is essential to use listed and labeled metal-clad cable connectors that are specifically designed for the cable type and size being used. These connectors provide a secure and reliable connection between the cable and the electrical enclosure, ensuring proper grounding continuity. Secondly, when terminating metal-clad cable at electrical panels or junction boxes, it is important to properly bond the metal sheath to the enclosure. This can be achieved by using a grounding bushing or a grounding locknut that is listed for use with metal-clad cable. The grounding bushing or locknut should be installed in a manner that ensures a tight and secure connection between the cable sheath and the enclosure. Thirdly, care should be taken to avoid damaging the metal-clad cable sheath during installation. Sharp bends or excessive pulling forces can compromise the integrity of the sheath and reduce its effectiveness as an equipment grounding path. The NEC specifies minimum bending radii for metal-clad cable, and these requirements should be strictly followed. Fourthly, when running metal-clad cable through walls or floors, it is important to protect the cable from physical damage. This can be achieved by using a conduit sleeve or other approved means of protection. The sleeve should extend beyond the finished surface of the wall or floor to prevent the cable from being damaged by nails, screws, or other objects. Fifthly, when installing metal-clad cable in damp or wet locations, it is important to use cable and connectors that are specifically listed for use in those environments. These cables and connectors are designed to resist moisture and corrosion, ensuring reliable performance over time. Sixthly, it is important to properly support metal-clad cable along its length. The NEC specifies maximum support intervals for metal-clad cable, and these requirements should be followed to prevent the cable from sagging or becoming damaged. Support should be installed in a manner that does not damage the cable sheath. Seventhly, when splicing metal-clad cable, it is important to use a listed splicing kit that is specifically designed for the cable type and size being used. The splicing kit should include all of the necessary components to ensure a safe and reliable connection. Eighthly, it is important to properly label all metal-clad cable circuits. This will help to prevent confusion and ensure that the correct circuits are de-energized during maintenance or repairs. Labels should be permanently affixed to the cable and should clearly identify the circuit number and function. Ninthly, it is important to inspect metal-clad cable installations on a regular basis. This will help to identify any potential problems before they become serious. Inspection should include checking for damaged cable, loose connectors, and improper supports. Tenthly, it is important to follow all applicable electrical codes and regulations when installing metal-clad cable. These codes and regulations are designed to protect people and property from electrical hazards. Ignoring these requirements can have serious consequences. Let's now delve into some specific scenarios and address potential concerns that may arise when using metal-clad cable as feeders. Firstly, consider the situation where the metal-clad cable run is excessively long. In very long runs, the impedance of the metal sheath may become a factor in the overall grounding performance of the circuit. In such cases, it may be necessary to supplement the grounding path by installing additional grounding conductors or by using a larger grounding conductor within the cable assembly. Secondly, consider the scenario where the metal-clad cable is installed in an area with high levels of electromagnetic interference. The metal sheath of the cable can provide some shielding against electromagnetic interference, but in extreme cases, it may be necessary to use shielded metal-clad cable or to install additional shielding measures. Thirdly, consider the situation where the metal-clad cable is installed in an area with high levels of vibration. Vibration can cause the cable and connectors to loosen over time, which can compromise the grounding performance of the circuit. In such cases, it may be necessary to use vibration-resistant connectors or to install vibration damping measures. Fourthly, consider the scenario where the metal-clad cable is installed in an area with corrosive chemicals or fumes. These chemicals or fumes can damage the cable sheath and connectors, which can compromise the grounding performance of the circuit. In such cases, it may be necessary to use corrosion-resistant cable and connectors or to install protective barriers. Fifthly, consider the situation where the metal-clad cable is installed in an area with extreme temperatures. Extreme temperatures can affect the performance of the cable and connectors, which can compromise the grounding performance of the circuit. In such cases, it may be necessary to use cable and connectors that are specifically rated for use in extreme temperatures. Sixthly, consider the scenario where the metal-clad cable is installed in an area where it is subject to physical abuse. Physical abuse can damage the cable sheath and connectors, which can compromise the grounding performance of the circuit. In such cases, it may be necessary to install the cable in a protected location or to use a more robust wiring method. Seventhly, consider the situation where the metal-clad cable is installed in an area where it is difficult to access for maintenance or repairs. In such cases, it is important to use high-quality cable and connectors that are designed for long-term reliability. It may also be necessary to install additional access points to facilitate maintenance and repairs. Eighthly, consider the scenario where the metal-clad cable is installed in an area where it is subject to frequent changes or modifications. In such cases, it is important to use a wiring method that is flexible and easy to modify. Metal-clad cable can be relatively difficult to modify, so it may be necessary to use a different wiring method in these situations. Ninthly, consider the situation where the metal-clad cable is installed in an area where it is important to minimize the risk of fire. Metal-clad cable is generally considered to be a fire-resistant wiring method, but it is still important to take precautions to minimize the risk of fire. This may include using fire-resistant cable and connectors, installing fire stops, and providing adequate ventilation. Tenthly, consider the scenario where the metal-clad cable is installed in an area where it is important to minimize the cost of the installation. Metal-clad cable is generally more expensive than some other wiring methods, so it is important to carefully consider the cost implications before selecting this wiring method. It may be possible to reduce the cost by using smaller cable sizes or by using a different wiring method in some areas. Let's explore some frequently asked questions regarding metal-clad cable and its applications. Firstly, is metal-clad cable suitable for use in residential applications? Yes, metal-clad cable is commonly used in residential applications for branch circuits and feeders. It provides good protection against physical damage and is relatively easy to install. Secondly, is metal-clad cable suitable for use in commercial applications? Yes, metal-clad cable is widely used in commercial applications for a variety of purposes, including lighting, power, and control circuits. It is particularly well suited for use in exposed locations where physical protection is required. Thirdly, is metal-clad cable suitable for use in industrial applications? Yes, metal-clad cable is often used in industrial applications due to its durability and resistance to harsh environments. It is commonly used in factories, warehouses, and other industrial facilities. Fourthly, can metal-clad cable be used in wet locations? Yes, but only if it is specifically listed and labeled for use in wet locations. Wet location metal-clad cable has a special jacket that protects the conductors from moisture. Fifthly, can metal-clad cable be used underground? No, metal-clad cable is not generally approved for direct burial underground. However, it can be installed in underground conduit. Sixthly, what is the maximum voltage rating of metal-clad cable? The maximum voltage rating of metal-clad cable varies depending on the specific cable type. However, most metal-clad cable is rated for 600 volts. Seventhly, what is the maximum operating temperature of metal-clad cable? The maximum operating temperature of metal-clad cable also varies depending on the specific cable type. However, most metal-clad cable is rated for 90 degrees Celsius. Eighthly, what is the difference between metal-clad cable and armored cable? Metal-clad cable has a corrugated metal sheath, while armored cable has a spiral or wrapped metal sheath. Metal-clad cable is generally more resistant to physical damage than armored cable. Ninthly, what is the difference between metal-clad cable and flexible metal conduit? Metal-clad cable is a complete cable assembly that includes conductors and a metal sheath, while flexible metal conduit is a flexible metal tube that is used to protect conductors that are pulled through it. Metal-clad cable is generally easier to install than flexible metal conduit. Tenthly, where can I find more information about metal-clad cable? You can find more information about metal-clad cable in the National Electrical Code, manufacturers' catalogs, and online resources. It is always advisable to consult with a qualified electrician or electrical engineer before installing or working with metal-clad cable. Understanding the nuances of metal-clad cable, its grounding requirements, and proper installation practices is crucial for ensuring electrical safety and code compliance. Always prioritize safety and consult with qualified professionals when in doubt.